Let's give it up for Molly.
Thanks, Molly.
Reminding us to record, however, the downside is I have to start all over. So we want to take the derivative of that ugly function. You know how to take the derivative, but it would be nasty. So I'm going to show you a new technique. Some of you would argue that the new technique is more difficult than the old technique. Could be, but it will help in some problems. So there's a couple steps to it, and it'll make sense as we work through the problem, and I'll do this example for you and show you how we're going to get our answer here. So step one is you take the log of both sides, natural log of both sides. And basic rule of algebra, whatever you do to one side of the equation, you have to do to the other side. So I can take the natural log of the left as long as I take the natural log of the right. Step two, do some logarithmic properties there, and then differentiate implicitly, which is a fancy term, which means use implicit differentiation. And then step three, solve for y prime. So after everything's said and done, we'll do some magic, and then we're done. This is especially convenient if you want to do something like what is y prime of 2, where you just have to plug a number in when you're done. However, you could also use it if you just want to know what's y prime. Okay, got these?
Nope.
Idiot. Yeah? All right, here we go. Let's do this bad boy. So step one, I took the natural log of both sides. Whoopsh. Step two, use some log properties. I'm going to leave the left side alone. So I'm just going to do equals, and I'm going to do some log properties to that. How can I apply log properties to that train wreck?
Who knows?
Top.
Good answer, Max. I'm sorry?
Natural log of the top minus the natural log of the bottom.
Well said. The natural log of the top minus the natural log of the bottom. Okay? Can we do some more there?
Yeah.
Luke?
You can move the 2, that exponent out to the front.
Excellent.
In 1/2.
Whoops, not a minus.
It'd be negative 1/2.
Minus 1/2 natural log of x squared plus 1. Anything else? No? Good. Okay, so this is the natural log of y is equal to that. So we simplified it a little bit. Next, take the derivative. So this will see if you learned anything yesterday. What's the derivative of the natural log of y?
Y over 1. Or 1 over 1.
Nope.
9.
Remember, it's in terms of y, implicit.
Y prime.
Say again?
Y prime. Over 1. No, over y.
Over y. What's the derivative of y in terms of x? 1 y prime. Okay. Implicit differentiation, remember that? Derivative of x squared is 2x. The derivative of y squared is 2y y prime. Anytime you take the derivative in terms of y, you got to stick a y prime on the end of it. We're okay with that? That's important. Oh, look, there's a y prime there. We're getting closer. What's a derivative of 2 times the natural log of x minus do? Are you raising your hand?
Mm-hmm.
Go.
2 over x minus 2.
Well done. Any problems with that? If we forget about the 2 there, the derivative of the natural log of x squared is 1 over itself, x minus 2, but we had a 2 floating out there. What's the derivative of 1/2 times the natural log of x squared plus 1? Taylor?
X over x squared plus 1.
I'm going to do it in stages so we don't lose anybody. So I'd have 1/2 times, what's the derivative of that, just that chunk?
Yes. Oh. 2x.
Are the lights on or off? No.
Both. True.
You got a point.
So what, no, I'm not waving to you, I'm blocking the projector. What's the derivative of the,
2x. Max.
don't wave at me, Max. Come over there and knock you into tomorrow. Go ahead.
2x.
Over.
X squared plus 1.
Okie dokie. So then, as Taylor mentioned, this would cancel with this, and we'd be left with x over x squared plus 1. Step 3, solve for y prime. Eric, lose the iPad. So y prime is equal to this mess, 2 to over x minus 2 minus x over x squared plus 1, all times y. Well, that would seem fairly nice, yes? However, what's y? Not 2.
2 over x minus 2 y minus
I'm not sure what you just said there, Max.
3. All right. No, don't you just, you know, like.
You can
Yeah.
You
do
stick that in.
pokey and you turn yourself around.
Yes, Taylor.
It's equal to the original equation.
Very good. It's equal to the original equation.
Yeah, that's what I was trying to say.
Uh-huh.
But I have a question.
Yes, sir.
Okay. So, when we have y prime over, no, natural log of y, so then you take the derivative of the natural log, so that just disappears and becomes 2 over x minus 2, like y.
Derivative of the natural log is u prime over u. Natural log of u, derivative is u prime over u.
Oh, okay.
Now, that's not real pretty, but it gets the job done.
Is that just your answer?
Done.
Okay, good.
Now, if you're feeling saucy, you could find a common denominator, simplify this, multiply it by that, but it's not going to get you anywhere, so just leave it like that.
But we never have to do that, or no?
Some of the problems, if they're simpler, you may have to,
But not.
but not this guy. No, I'd
That's ugly.
just leave it alone.
Everyone's beautiful.
How could we make things more interesting?
Trig.
Trig, yes, but we're not going to. Desi.
So we did, so you find y prime and then you like multiply by y and y equals.
Right, because I want to get y prime by itself. I want to know what the derivative is.
Yeah, and then so you, y equals x minus, oh, but it's not the natural log. It's just
No, because remember, our step 1 is take the natural log of both sides. If we go back a slide, you'd see that y is equal to this business here.
Okay, so we just, okay.
Then you just sub that back in for
Then you
y.
just multiply it, okay, so that's what I'm.
Make it more interesting.
Yes.
Take the second derivative.
Take the second derivative.
Is
Wouldn't that be fun?
You
No.
would do that to us.
Was that the derivative?
Cowards.
Let's do it.
If you, I'm not going to because it gets really ugly. But notice that if I take the second derivative here, I'll get y prime, well, sorry, y double prime over y prime. And then I got to take the derivative of that mess. This is not a good example to do a second derivative. I'm just telling you what could possibly happen. Then I take the derivative of this. When I have to multiply through to solve for y double prime, I'd have a y prime over here. And what's y prime equal to? This mess. So it creates a vicious cycle. Okay? We're pretty much just going to use it for the first derivative and use it on ugly equations like that. Okay? It's not something where you're just going to be sitting around and saying, well, I got to take the derivative of that. Hey, let's try logarithmic differentiation. No, it'll pretty much tell you, here's what you need to do logarithmic, or solve this problem using logarithmic differentiation. Okay, so it's another technique to take derivatives of ugly, nasty equations. Okay, we good? Questions? Nope. Outstanding. Let me get rid of this.